Glyceraldehyde-3-Phosphate is a crucial metabolic intermediate in the process of glycolysis, which is the metabolic pathway that breaks down glucose to produce energy in the form of ATP, adenosine triphosphate. Glyceraldehyde-3-Phosphate is an important molecule that plays a central role in the conversion of glucose into pyruvate, which is further metabolized to produce ATP. Chemically, Glyceraldehyde-3-Phosphate is a phosphorylated sugar molecule, specifically a triose phosphate. It is formed during the early steps of glycolysis, when glucose is broken down into two molecules of glyceraldehyde-3-Phosphate. This process involves a series of enzymatic reactions and serves as the starting point for the subsequent energy-yielding steps of glycolysis. Glyceraldehyde-3-Phosphate is a key metabolite that is further processed in the glycolytic pathway to generate ATP and NADH, which are essential for cellular energy production. Additionally, it can also be used in other metabolic pathways, such as the pentose phosphate pathway, to generate other important biomolecules needed for cellular function and growth. Overall, Glyceraldehyde-3-Phosphate is a central player in the metabolism of glucose and serves as a critical link between the initial breakdown of glucose and the subsequent energy production and biosynthetic processes within the cell. It is important to note that the DL prefix in the name indicates that the compound contains both the D and L enantiomers, which are mirror image forms of the molecule. These enantiomers have identical chemical and physical properties, but differ in their spatial arrangement. In biological systems, enzymes typically interact with specific enantiomers, and the presence of both D and L forms of glyceraldehyde-3-Phosphate may have implications for its interactions with enzymes and metabolic processes in living organisms.